All right, today is January 10th, 2011. We're on lesson 8.2. We're going to be doing cosine law. This is a little different from sine law. Now, it's important to know how to set up a triangle. We already discussed this yesterday, that the angle and the side with the same letters are always opposite of each other. And we said we can call any angle and any side any letter we want. For cosine law, I'm going to teach you just this formula. Technically, you could write this 3 different ways, but we're only going to learn it this way. And instead, what we're going to do is whatever our variable is, we're going to call that side C. So you always have to remember to name side C the side where the variable is, or the angle where the variable is. We're always going to call that side C. Kind of like with Pythagorean theorem, where C is always the hypotenuse. This time we're always looking for the variable. Doesn't matter where it is, we always call that side C. Okay? So, we're going to go through the very first example in your book. Example number 1. It says that a boat is sailing north through a narrow strait. Through one particularly narrow section, a lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly east of the lighthouse as shown. What is the width of this section of the strait to the nearest tenth of a kilometer? So they've given us a diagram. We have a lighthouse here. Okay. It's got its lights going out. I like those lights. Looks like a guy. There are the lights. The lighthouse. Okay. And we have our boat. And we have our rock. That one. That took effort. Okay. We know that the lighthouse is north of it. Or sorry, the lighthouse is north. It is north. It's just not directly north. We don't exactly know how far these things are. And directly east of the lighthouse is a rock. Okay. So our triangle is going to look like this. It says that the angle from the lighthouse to the two objects is 26 degrees. It says that the distance to the lighthouse is 4.2 kilometers, and the distance to the rock is 4.5 kilometers. So we want to know how narrow this strait is. In other words, this is our, I guess you would call it our x. We're going to be solving for that side. Okay? Now, first off, sine law is usually easiest to use. So I'm going to quickly look at sine law. And remember, we need the ratio in order for the sine law to work, right? We need to have an opposite side and angle. One of these ratios has to be complete. Do I have an opposite side and angle anywhere in this triangle? No. So I cannot use sine law to solve for this. Okay? So we're going to look into cosine law. I have 2 measurements, and I have a third measurement that is opposite of a side or angle. Okay? So what did I say we're going to call this? Of our variables, A, B, and C, which one is our x and 26 going to be? That'll be our side C when we name this. Our angle, 26, will be angle of 26 degrees, and x will be our side C. The other 2 could be more arbitrary. We'll call this A and A, B and B. Okay. So we have these measurements. We're going to put them into our cosine law. So we take our law here. So, our side C, what did we call it? We called it our x, right? I can leave it as C if I want, or I can replace the C in the equation with x. So let's call it x. It's going to be squared. Is equal to, what was our side A? 4.5. So 4.5 squared plus what is side B? Good. Side B is 4.2. That's going to be squared also. Minus 2 side A is 4.5. So multiplied by 4.5. Side B is 4.2. Multiplied by 4.2. And finally, cos, and what was angle C? 26. Good. Good. So we had 26. So we've left all our variables here. So we have all our variables here and we've plugged them all in. We're looking for our x in this case. Now we have to follow BEDMAS while doing this because this can be a bit confusing. First thing I'm going to do is I'm going to deal with my squareds. I have 4.5 squared. It's 20.25. So I'm going to write everything in black from here on in. I color-coded it so we can get used to the triangle. So I have x squared is equal to 4.5 squared we just did is 20.25. 4.2 squared, 17.64. Now, I'm going to equate 2 times 4.5 times 4.2. Okay, I'm going to do that all right now. So we have this negative sign here. And we can either say this is negative 2 or we can just bring down the 2. I'm going to say it's negative 2 times. So we have 2 negative times 4.5 times 4.2, negative 37.8. Okay, so I put subtract 37.8 and cos 26. I'm going to leave that for now. Still multiplied. That still means multiplied by, okay? This cos 26. We have to equate what cos 26 is and then multiply it by the 37.8. I'm going to add my two terms together. 20.25 plus 17.64. 37.89. Subtract 37.8 times cos 26. Now I have to stress the next step. Many people make this error. They subtract these two numbers. According to BEDMAS, we do the multiplication first. So I multiply cos 26, I plug in cos 26, then I multiply that number by 37.8. Then I deal with the subtraction. Okay? So 26 cos gives us that number there. To keep it very accurate, I'm going to instantly multiply by 37.8. So we're going to have, should have been negative 37.8. So I'm going to leave that subtraction sign there. So I didn't include it. Subtract 33.97. Okay. I'm going to subtract these two numbers, so we get 37.89 subtract 33.97, 3.92. And remember, that's what x squared is equal to. In order to isolate x, what do I have to do to both sides of this equation? Square root, that's right. I square root both sides. On the left side, I'm left with x, which is what we're looking for. Square root of this number is 1.97. So 1.97 kilometers, which is, if we were to round it, it is approximately 2 kilometers. So from looking at this, let's get the entire page. Okay, we discovered that that small straight is 2 kilometers wide. Okay, example number 2. They've given us triangle DEF, and they've given us some measurements. Side D is 4.9, side F is 6.2, angle E is 64 degrees, and side E is 5.98 centimeters. Okay, so what that means is I need to create this triangle because they have not given me a diagram. And we're just going to name it. Okay. Looking at the sides, it looks like I drew this the longest, so this would be 6.2 centimeters. So this would be my side F. This will be angle F. Okay. I'm going to draw the other two sides. This one looks like it could be 5.98 centimeters. This is not the scale. I'm just estimating. Angle E, which then leaves this as side D, and angle D. Now, according to Pythagorean's theorem, we use A, B, and C. I'm trying to find this angle here. Oh, sorry, and we know angle E is 64 degrees. We're looking for this angle here. So what am I going to rename side F? C. Remember, whatever we're looking for, we're going to call side C. So this is my angle C. This is now my side C. And I can just name the other ones A and B, whichever way I like. So that will be A, and this will be B. Okay? So now that we have these, just underline them, because there are a lot of letters going on here. Let's make sure we know what each is. Okay? We've renamed this triangle so we can put it into cosine law. We're going to do that each time. Always rename your triangle. Even if they use the letters A, B, C, and they tell you to look for side B, you need to rename the triangle so that that B is now side C. We're always looking for side C with our law. Okay? So, we take our cosine law and we plug variables in. Side C was 6.2. So 6.2 squared is equal to, side A is 5.98 squared plus side B is 4.9 squared. Subtract 2 times side A, which is 5.98. Side B was 4.9. Cos, and what do I call C? C. You can just call it C, you can call it X, whatever you like. That's the variable we're looking for. So that's the end of the equation. We either are looking for side C or we're looking for angle C whenever we use cosine law. Okay? Now, I didn't bring this up. Technically, I could have used sine law to solve this. I have a ratio here. Okay, but let's say we didn't have that 64. Like clearly we didn't use it in the cosine law. Let's pretend that was never there and we only had the sides. Okay? So, I'm now going to start to equate things. 6.2 squared, 38.44. 5.98 squared. Let's round this one to 2 decimal places. 35.76. 4.9 squared. 24.01. Okay, negative 2 times 5.98 times 4.9. So it looks like we're subtracting. Negative 58.604. And we're still looking for cos C. Okay? Now remember, this is multiplied by cos C. So what I need to do is I need to start isolating C. I'm going to bring these two numbers to the other side of the equation. Okay? Now this is a tricky part. This is where a lot of people get confused. When I bring 35.76 to the other side, what does it become? That's right, it becomes negative. Sure, we can add, you know what? Let's do it that way then. Let's combine them first, then bring them over. That's a great point. You don't have to do it all there. We have our 35.76 plus 24.01, 59.77. Subtract 58.604, cos C. Now remember, again, I can't stress this enough, do not subtract these two numbers. We need to this is multiplied by cos C, so we can't subtract them according to BEDMAS. We're going to move 59.77 to the other side of the equation. 38.44 subtract 59.77 is equal to, what's on the right side? Good. It's still negative. Negative 58.604 times cos C. We combine these two numbers, 38.44 subtracted by 59.77, get a negative number, which makes sense. Negative 21.33 is equal to negative 58.604 times cos C. Okay? Now I still got to isolate C. How do I move 58.604 to the other side? That's right, we have to divide because it's technically times cos C. So we divide, it's not crossing out, it's a division sign, both sides by this term. These two will cancel out. So on the right side, we're left with cos C. We'll equate this. Negative 21.33 divided by 58.604 when it's negative is equal to positive 0.363968. Right? Made a rather large number. I'm still not done. I got to isolate C. How do I get rid of cos? Okay, what does cos become when it's divided by or when we move it to the other side? Yeah, it's that inverse to the power of negative 1. So inverse cos, okay? So when we bring that over, we get inverse. So put it in red here. Cos inverse to that number, 0.363968, is now equal to C. So in our calculators, we have this number, shift second function cos, 68.68. Or 65 degrees, which we can say C is approximately, I guess 69 degrees we'll say, for rounding it, okay? So, those are the two options. You're either solving for a side or you're solving for an angle. Either way, you have to manipulate the formula, okay? Remember, your variable is always side C. That's how we're going to set. So homework 409, 1 through 5 is a lot of what your quiz will look like. 7 and 14 and 17, they're harder, but if you can do them, you're doing well.